Holiday Lights at Com is back with 3 million lights, new colorful displays, and many of your old favorites. See our salute to active duty military and veterans. For about the price of a movie ticket, you, your family, and friends can enjoy this 3 million light extravaganza with unlimited free carousel and train rides on board the Candy Cane Express. And every dollar you spend at Com stays at Com. Holiday Lights at Com is on Alfred Hale Highway in Northeast Bakersfield between Lake Ming and Hart Park. Just look for the lights in the sky.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Marty.
And I'm Chuck. Our phone tuners are here until 5:30. Give us a call at 636-4357 if you have some questions about your math work. You can call toll-free from San Luis Obispo and other outlying areas at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show live online at dothemathonline.net and look for us on social media, Facebook, Instagram, Twitter, and YouTube, and you can contact us with Skype now too.
There you go. Well, how was your road trip yesterday?
It was cool. It was really fun to go out there to Horace Mann, even though we had some technical difficulties.
Well, that's all right. You know what? The
still
kids
fun.
were able to do their work. We were able to get them on air. They were on. You had a good visit.
Yeah, it was
Everything
great.
went as smooth as possibly could be, right?
It did, yes.
Now, that's the first time you've been in a school
Right.
this year, because I know you were out at the fairgrounds.
Yes.
And we have some other special assignments for you to go on.
Oh, gosh. Okay.
But anyway, later on this afternoon, we'll be visiting with some friends out at COM because there's a lot of stuff going on at COM right now because there are millions of lights, and we can see a little footage right there. Because every time a student phones in and we do one of their math problems on TV this week or next week, that student will automatically win 2 tickets to Holiday Lights at COM. No need to wait for the drawing at the end of the program. You automatically get it.
Wow.
And the twins, we had twin boys on last year, I think it was.
All right.
And they had asked, well, if I call, can I get a pair of tickets? And I'm like, by all means, you can get a pair of tickets. And he's like, well, my brother, if he calls, can he get a pair of tickets? And well, you're a different person, so by all means, you can. So if you've got that many people in the family, you all want to call, but you can go ahead and everybody can have a pair of tickets. As Chuck said, we do have phone tutors here available until 5:30, but before we get to that and our special guest of the afternoon, let's first take a look at today's Math in the News. All right, today's Math in the News has to do with something that if something happened to this service, this industry, this country and the world would be in a lot of problems.
Okay.
Transportation of goods.
Oh, okay.
Okay,
Yes.
because you can do it with a lot of speed using airplanes,
Trains.
trains, but trucks. The amount of goods that trucks move every day is astounding.
Wow.
And I was reading an article, and it was somebody had brought up the question, like, why are there 18 wheels on a truck? So then the article went into a little bit about it, so I figured, all right, well, let's take a look at a big rig and see exactly why there are 18 wheels on it instead of a couple of others. Would you, if you were offered a position and somebody said, you know what, we will pay you your teaching salary plus more, obviously it would have to be more, to drive a big rig for a year, going all around, you could kind of plan the routes a little bit, but would you drive a big rig for a year?
No.
No?
No, I'm good.
You're good? No desire to do that?
I have zero
You can see
desire
all
to do
sorts of the
that.
country and,
Yeah.
no? You wouldn't want that?
No, I'm
No?
good.
Chuck,
That's
what about yourself?
Actually, when I was a kid, a friend of mine down the street and I, that's what we were going to be when we grew up. We were going to be long-haul truckers.
Okay.
Neither one of us did it, but there,
Well,
was a
There was a
TV
dream.
show.
There
There
was
was
a
a
dream.
TV show where they had, long-haul truck drivers, and they went all
The
around.
convoy, what was, I remember there was
Moving
a
on.
show.
Moving on.
Okay.
Claude Akins, I believe, if I'm not mistaken.
Well, my brother was a truck driver for a while and then became a fireman, drives the fire trucks.
Oh, that would
And
be
then
cool.
to see him back those in,
Oh,
because the garages probably have an inch and a half on each side. I mean, I'm
Yeah.
exaggerating a little, but I mean, to maneuver those around
that's
takes a lot of
probably
skill.
why. That's probably why we didn't become truck drivers, backing those things out. Forget it.
Yeah.
No, thank you.
So, anyway, containerization, the word of the day.
It
All right.
really is. Wow.
Yeah. So an average 40-foot container can carry up to 60,000 pounds of cargo. The United States Department of Transportation restricts limits to 80,000 pounds. All right. So they don't want you carrying any more than 80,000 pounds on the road.
Wow.
You need, okay, so 12,000 pounds are allotted for the steering axle and 2 tires. All right.
Okay.
20,000 pounds per single axle and 4 tires afterwards. So an 80,000 pound trailer needs 4 axles, which is going to have 4 tires per to get the 16,
Right.
and the 2 for the steering axle.
Right.
So that's how you get the 18 wheels. All right. So I just thought that was kind of interesting because the impact on the road.
Is significant.
Oh, yeah.
Right, because you're just asking for more road repair after that. And I guess they're coming up with something where they're going to go, we want to carry more weight. We'll add more axles and disperse the weight over. But then trying to drive something like that,
Yeah.
I mean, these things are
Gets
pretty amazing
longer.
what they
Yeah.
do already.
And in other parts of the country, you don't see them in California, but there are double and triple trailer trucks on some of the interstates around the country. They're
Not here.
huge. Not here. No.
So I figured, all right, we're doing some multiplying. And our guest today is learning how to multiply. So I figured we'd introduce some new ways of multiplying. Have you guys seen this multiplying with lines?
Just once.
I
and
have, yeah.
It
Last
was
Hey.
weird.
It was
Yeah,
weird.
relatively
I didn't
new
figure
that
it
I've
out.
seen this as well.
Yeah.
So 23 times 34, and you do this with lines. So the 2 right here represents the 20, these 2 green lines. Hopefully you can tell the difference. I tried my best to do these in color so that you can see the difference.
Okay.
And here are the 3 ones. So 23, and then you go the other way. Here's 3 for the 3 tens, 30, and 4.
Okay.
All right. Then what you do is you draw lines to separate these sections where they overlap. All right. So you see how these overlap right here?
Oh, the end pieces.
Right.
Yes,
So we
the
have to draw a
corners.
line between this and then the center, and then we have the ones on the other end.
Okay.
All right. So we count these all up. All right. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18.
Wait, what are you counting? Squares or
The
pieces?
intersect, so the pieces. So 1,
where
2,
they
3,
cross.
4, 5, 6, 7, 8, 9, 10, 11, 12.
Oh, okay.
So we have a 2 there, but we had 12, so we're going to carry 1.
Okay.
With me?
Yes.
All right.
with you.
So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we had a 2, and now we have an 8, but we needed to carry another 1 over.
Carry the 1 again.
So it's 1, 2, 3, 4, 5, 6. With the one we carried is 7. So it'd be 782. So we can see it right there.
Ah.
Now,
okay.
some see this as easier. It is simply another way,
Yes.
is all we're presenting.
Yeah.
All right. So here's one. So we can see 22 by 30. So here's the 20,
Yep.
2 by 30, 2.
Okay.
All right.
Yeah.
So we count them up. 1, 2,
4.
3, 4. So we're going to end with a 4. And you
4
can
is the
tell
last
right
number.
now, 22 by 32, the last digits are 2. So you know it has to end in a 4.
Right.
So this is working for us thus far.
Yeah.
We don't have to carry anything over.
Right.
So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be a 0.
Carry the 1.
Carry the 1. So we have 0, 4.
Uh-huh.
1, 2, 3, 4, 5, 6 plus our 1 is 7. So it should be
704?
704. So if you wouldn't mind, take
Oh,
your trusty
let me check.
calculator and
What
make
is
sure
it?
that we're correct.
22
by
times
32.
32. 704.
Oh, look at how that
works.
works.
How
It
about that?
worked.
So
Nice.
perhaps a little later on, we'll have our guest take a look at some of this multiplying with the lines, or maybe we'll have her do another way. Since, look at, she's over there going, nope,
so
I don't want to
excited.
do any of that. And she's only learning how to multiply right now. But these are some fun little tricks and other methods. And you never know. I mean, somebody might come on to one of these and go, you know what, this is the easiest thing in the world. I see this without a problem, and
Well,
I'm
it's-
just going to go with this. And you
yeah.
can multiply 3-digit numbers. There are all sorts of things you can do with this. It works if you know how to set it up.
Right.
Right.
And anyway, that is today's Math in the News. And that's what I wanted to do. I got found something to do with the 18 wheels on the truck
Right.
and things like that. 636-4357 is the phone number. We do have phone tutors available until 5:30. And every time somebody phones in, we give them automatically a pair of tickets to Holiday Lights, as we will do right now with Gabe. Gabe, how are you today?
Good.
And you're a student at Valley Oaks, correct?
Yes.
And what grade are you in?
4.
All right. As soon as you're ready, Gabe, let's hear the math problem that you're working on.
79 times 73.
79 times 73?
Yes.
Okay.
All right,
We
so,
should do it with
Chuck, you want to do it
lines.
with the lines? I'm
Gabe.
only kidding, you know.
so we're doing multiplication, so we might check our answer, but let's go ahead and do this problem since we're doing multiplication and we're going to be doing multiplication later. Let's go ahead and set this problem up and do the problem using the numbers. Let me ask you, which number would you like to put on top? 79 or 73?
79.
So let's put the bigger number up on top. So I'm going to go 79 times 73. So we're going to do this problem vertically, right, up and down instead of horizontally across. All right, so
Yes.
let's go ahead and do this. We just need to know your multiplication tables, right? So your multiplication facts really make the problem easier. The other thing that makes the problem easier is making sure you keep everything lined up. So neatness counts, okay?
All right.
All right, so what's 3 times 9?
3 times 9 is 27.
27. So we know we're going to put down the 7 and carry the 2. And then 3 times 7?
3 times 7 is 21.
Plus the 2, 23, right?
Yes.
Now again, neatness counts because we started and counted, multiplied by the 3 and started right here. Now we're going to multiply by the 7, and that means we're going to start here. So what do you do to make sure that you move over? Some teachers have you put a 0 here, right?
Yeah.
Because we're actually multiplying by 0. Some people put an X there. So we think of this as 73, so that's a 70. So let's go ahead and think of that 70 and put a 0 there, okay?
Okay.
That just tells us that we're going to start underneath the 7 and we're going to start putting our answer right here. So what's 7
All right.
times 9?
Hmm?
7 times
7
9.
times 9 is 63.
63. So we're going to put down our 3 and carry the 6 now. Make sure we don't use that 2. And then 7 times 7.
7 times 7 is 49.
Plus the 6 that we carried.
55.
55. So again, making sure that everything keeps lined up. We put the 0 here, then when we started multiplying by the 7, we started here, here, and here. Keeping things lined up makes sure that when we add these together to get our answer, we'll get the right answer. So now the addition is pretty easy, isn't it? 7,
Okay.
3 and 3 is 6, no carrying. 2 and 5, that's easy, that's 7 and 5. So it looks like our answer should be 5767 or 5,767. Now we could do this problem using the method with the lines, but that's a lot of lines to be drawn.
Right, when you get to
Counted.
the 70 and the 9, yeah, there's...
But that should be our answer, okay? And thanks for the call.
Okay.
Nicely done. Thank you on that, Gabe. Do remember, if you have some other problems like that, we do have phone tutors available until 5:30. And that's one thing, because when I did the examples for the Math in the News, it was like, all right, do I want to do 88 times,
yeah,
97 or
97.
something like that? But as I said, there are some students that see this and
Well,
They
it's
just whip right
visual-
through it.
It's doing multiplication
Easy.
visually. so
Visually,
it's
exactly. The
fine.
patterns and
Yeah.
seeing it is, yeah.
Now, Gabe was in 4th grade, and our student today is in 3rd grade learning multiplication, and I could see she was working on some of those multiplications in her head while you guys were working on that. And we'll get to young Vienna in just a little while. Right there you go. Anyway, right now we're going to go visit with some folks out at COM. They have holiday lights at COM going on, and Marylou is out there ready to go. Hello, Marylou.
Hi, Mike. We're out here at Holiday Lights at COM, and I am with Josh Barnett for Lightasmic. Did I say that correctly?
You did, yes.
Awesome. This is so amazing what you do every year. Can you kind of give us a brief history of how you got started with doing lights and how you came here to COM?
Sure. Well, I started doing lights just as a young kid, and the display that I was doing got progressively bigger. The last year that I did the display at my parents' house, it was 185,000 lights,
Oh,
and just covered everything. After that year, we knew it had grown too big for the neighborhood. So luckily, I got in touch with Mike Steyer at Steyer's RV, and we brought the display to his parking lot. That was in 2002. And in 2003, we brought the display to COM.
now when you started a display here, did you do the whole entire COM, or did you have just a small section that you worked on first?
You know, we started out as a collaborative effort. We had a lot of people involved, and we still do. We still have several people that it takes to make it all happen.
Yeah, well, it's really amazing. All the lights. Now let's talk about the lights.
Okay.
How many lights are out here?
We have 3 million lights total.
3 million. Okay,
Yeah.
I use what? Maybe 800 lights in my house. 3 million lights, my goodness. And looking around, they're all different.
They are.
Can
Yeah,
you kind of
yeah.
explain to what we have here?
Sure. Well, let me walk over to this display here. So we use rope light, which is this one right here. We use C7 LED bulbs, which is this one. And we use them for different things. So we use the rope light whenever we need something really detailed. And so we can bend it and curve it to the shape. And then we use these whenever we want a pop of color and where we can do more widespread with the lines, where they're not so intricate. And then after that, if we walk over to this tree here, you can see we put these LED minis in the trees. We use these strands. They're 50 bulbs per strand, so they're 25 feet long because they're 6-inch spacing. And we use these for all of our trees.
Okay, now if I want to get this look at my house, which I don't know, how many strands would I need?
This is several hundred strands for this tree, just because they start from here at the trunk and they go all the way to the top.
Wow. Okay, so my little 3 strands aren't going to do it, are they? Okay, how many people does this take to get this all done?
Okay, so we start installing middle of September, and we have 10 guys out here.
Wow. Now, I know you guys start really early because a
We do.
friend of mine who runs out here, she sees you guys early in the morning. What
Yes.
time do you guys start
We
at?
typically start at 5 a.m.
And you guys work until,
Up to about 1:30, 2 o'clock.
okay.
And the reason we do that is so that every morning we can come in and we can turn on and see what we've done the day before.
Exactly, because it's still that dark time.
Yeah.
Is it easier to put them up when they're lit so you can see what's happening as you?
It is actually what we do is we start during the day with the 5 a.m. to 1:30 early on, and then we start doing a night crew as it gets closer to Thanksgiving before we open. And so then we come in and tweak and fine tune everything.
And when do you guys open? What's your day that you open?
This year we opened the Friday after Thanksgiving.
Oh, so you've been already having
Yes.
a lot of people out
Yes.
here. So you start out that first Friday, Black
Yep.
Friday.
Yes. Yeah.
And when do you close?
We go until I believe it's January 3rd.
Oh, okay. So sometime after Christmas,
Yeah.
the whole, almost like that whole holiday season. at the
Yes.
end. Very nice. Now let's talk energy usage. That's another thing
Yeah.
I'm like really jealous about because you can see my extension cords everywhere. Now, how do you guys hook everything up?
One of the nice things about the LEDs is they do use so much less power. We used to be incandescent when we first started, and we were running about 6,500 amps. So we've dropped that down to about 2,000 amps by
Wow.
switching over to LED. And to run our power, here you can see we've got everything plugged into a extension cord here, and then those extension cords plug into another extension cord, and then that feeds into our main power lines. So if we trace like this orange cord here, and we plug into this power, this fill box here, and that's what gives us our power.
Wow. And how many of those do you have located around the park?
I don't have a number, but we have a lot of them.
Yeah.
Yeah.
Wow. This is really Josh, you guys do such an amazing job. Well, again, we opened at Black Friday. They started at Black Friday, correct? And we go till January 3rd. And we're going to have some more from here at Holiday Lights at Com. Back to you, Mike, in the studio.
For that, Marylou, do remember that you offered to put any lights up high in the trees and things for them. Remember you were talking about that yesterday? If they needed anything high, you were ready to scale whatever needed to be done?
Yeah.
Anyway, we'll be back with Marylou and all of our friends at ACOM and learn more about the holiday lights.
I want to see her climb a tree.
That would be fun. I don't know if we're actually going to let her climb a tree with the Do the Math shirt on.
That's
Maybe she can
true.
do it on her own. But anyway, I had an opportunity to work at one of the oral language festivals in the county last night. And while we were waiting for the results to come back, I was doing some puzzles with the kids and things like that.
Mm-hmm.
What is the largest number when spelled out is in alphabetical order? And we've done this on the program before.
Oh, I think I remember this.
The largest number you can have where when you spell it out, it's in alphabetical order. And the students were taking some time, and somebody eventually got it. But one young man said, a lot. So A-L-O-T, it is in alphabetical order, but I said that's an amount, not a specific number.
And also not one word.
You're right. Well, some people, a lot or a lot.
Yes.
Right. So can you think of it real quick? Otherwise, we'll go ahead and just throw the answer out. And
I don't know. I got nothing.
Chuck and I have already seen this age.
I think it's something like
I don't
cheeky,
think
like
you have.
alphabet
You
or
have
something
not.
like that, but it's not alphabet. But yeah.
40.
40.
F-O-R-T-Y. Alphabetically in order, and that's the highest number you can get in alphabetical order.
Oh, number, not, I was thinking word. I was thinking.
Well, when you spell it out, it would be in word
Oh,
form.
that's true.
But anyway,
40.
We'll get another one later on.
Okay.
636-4357 is the phone number. Phone tutor's here until 5:30. Kyle, how are you this afternoon?
Good.
And you're a student at Sing Lung. What grade are you in?
6th grade.
All right, as soon as you're ready, let's hear that math problem.
It's blank over 6 equals 6 over 9.
Blank over 6 equals 6 over 9.
And I have to find the unit rate and the rule.
The unit rate and the rule. Is this right? So you have blank over 6 equals 6 over 9?
Yes.
Is that right? Okay. Well, so let's see. There's a few ways you could do this. Would you remember a way that your teacher taught you so that I can kind of piggyback off of that instead of showing you something completely different?
She told us to find either if the number gets bigger from the bottom to the top and the numbers on the top
Okay.
and the bigger numbers on the bottom,
Uh-huh.
she told you to divide.
Okay.
And if the number was smaller on the bottom and bigger on the top, you would multiply.
Oh, interesting. Okay. Let's see here. Well, we've got a number smaller here on the bottom than on the top, right? So it asked the first thing for a unit rate. Is that correct? Is that right for the unit rate?
Yeah.
Okay. So for the unit rate, a unit rate is a fraction that has 1 on the bottom. Like it's 1 unit. So it's like how much out of 1. So we have a fraction, but we don't have 1 on the bottom. So what we can do here is we can actually divide this out. I think this is going to be ugly, but we could do this. So what goes into both 6 and 9? Let's go ahead and just reduce this as far as we can go first.
3 can go into 6 and 9.
Is there a number that goes into both 6 and 9 that we can divide it both by? So I'm just going to reduce the fraction. Are you with me? Can you hear me?
Yeah.
Oh, okay. So 3 actually goes into 6 and 9, right?
Yeah.
So how many times does 3 go into 6? I'm going to divide it by 3.
3 goes into 6 2 times.
Good. And how many times
9.
does 3 go into 9?
3 goes into 9 3 times.
3 times. Okay, so far we have, so now we can reduce it to 2/3 equals something over 6. So this I can actually find my blank spot. Did it ask you to actually find what the blank number is? Is that right?
It says find the unknown value.
Right, so just
Unknown
find what the
value.
unknown value is.
Right, okay. So now we can actually do that a lot better. We still don't have our unit rate, which I could show you to do in just a second. But you can actually figure out what the blank is now, because does 3 go into 6? See how 3 and 6 are on the bottom? Okay, so I can actually, you know how I reduced the 6/9? I can actually turn this fraction back into a number with 6 on the bottom. So what would you multiply 3 by to get 6?
Times 2.
By 2. So if I multiply that by 2, I would get 6 on the bottom, right? But what would I have to do to the 2 on top?
Times it by 2.
Right? I'd have to also multiply it by 2. You're right. So 2 times 2 is what?
4.
4. So 2/3 is the same as 4 over 6, right?
Yes.
So see how 2/3 equals something over 6? So do we know what that something is now? What do we have? It's what over 6?
4 over 6.
Yeah, 4 over 6. So my missing unknown value is 4. So there's one answer. So the unknown value is 4. Now she asked for a unit rate, right?
Yeah.
Which means we need to actually divide this fraction all the way out so we get 0 on the bottom, which what we would do, we could either take 6 over 9 or 2/3. 6/9 and 2/3 are the same thing. I'm going to go ahead and take 2/3 just because it's smaller, and you actually would just divide it. So over here we would do long division. I would put my 2 inside, right, and my 3 outside.
Mm-hmm.
Okay, so how many times does 3 go into 2?
0.
0 times, very good. So then I put my decimal place there, right, and add a 0. How many times does 3 go into 20?
3 will go into 26 times.
6 times, because that would be 18, is that right?
Yeah.
So now we would subtract, and that would be 20 minus 18, is that 2?
Yeah.
Good, bring down your 0. So it looks like we have 3 into 20 again. So what does that mean?
66 for Peter.
Yeah, it's just going to keep repeating, right, a bunch of 6. So do you remember how to write repeating decimals?
Yeah.
So it's what, 0.6 with the bar over it, right?
Yeah.
So there, it's 0.6 with the bar over it, and that is actually our unit rate, because that's the same as that over 1. So there's my unit rate, which is what they asked for, right? So 0.06 bar over 1, which looks really ugly, but it's actually now a unit rate. And my missing number was 4. Did we answer all the questions?
Yeah.
All right, well, thank you for calling in. That was awesome.
Nicely done right there, and we certainly hope you enjoy the trip out with the 2 tickets to Holiday Lights at Com. We do have phone tutors available until 5:30. The phone number's at the bottom of your screen periodically throughout the program. In studio with us right now, the hardest working 3rd grader I know. How are you, Vienna?
Good.
Why don't you let everybody know where you go to school?
I go to school at Ronald Reagan Elementary School.
And how things going over at Ronald Reagan Elementary?
Excellent.
Excellent? What's the hardest thing about 3rd grade so far? All right, so you know what? I think they cannot, so what I'm going to do is here. I'm going to get your hair out of your way there. Maybe that'll help them hear you a little bit more, all right? And make sure you're really loud. So the best thing about 6th grade, you're not there yet, soon enough. 3rd grade.
Math.
You like the math?
Yes.
All right, well, you know what?
her shirt
We're
says
going to make you do some math, and we'll do that right after this. Well, today we're in Maricopa. We're at Maricopa Middle School, home of the Indians, and today we're here to... Well, today we're at Maricopa. We're at Maricopa Middle School, and with us right now, 7th grader Caitlin. Are you ready to work on a word problem? All right, why don't you go ahead and grab a marker right there. Why don't you go ahead and read the problem to us first?
A 6-foot man has an 8-foot shadow. How tall is a tree with a 20-foot shadow?
All right. How are we going to go about figuring this out?
I think you can subtract 6 from 8, and 8 is 2 more than 6. So a tree with a 20-foot shadow should be 18.
Could be, and it's probably close, because that's a good way to estimate it. You know that the man is less than the shadow, right? The length of the man is less than the shadow. So if you have a tree that's 20, reasonably you're thinking it's going to be less
Yeah.
than the tree. Okay? How about we set up a proportion?
Okay.
All right? So we have a 6-foot man. All right? 6-foot man is to an 8-foot shadow. All right? And that is going to be proportionally equal to our other fraction, all right? The other part of the proportion here. So we have the man on top and the shadow on the bottom, all right? What other information do we have here?
We have how tall the tree is in 20 foot. We have
Okay,
how tall
so,
the tree's shadow is.
right. So where would the shadow go, on the top or the bottom?
The bottom.
The bottom. So why don't you go ahead and write that in there? And we want to find out how tall that tree is, right? Okay, so what we're going to do is equivalent fractions. You worked with equivalent fractions before?
A little bit.
A little bit. Let's do one right here. Okay, we have 1/2 is going to be equal to something over 6. Do you know how you would get the answer to this problem?
Can you multiply them?
Exactly, right? If we go from 2 to 6, what do we have to multiply by?
3.
Right, so we go 2 times 3. So up here we go times 3. And 1 times 3 is?
3.
So we can see that 1/2 is the same as 3/6. Okay, now there's another way to do it also, because sometimes the numbers don't work nicely like that. The 3 we didn't have up there, did we?
No.
Okay. So what you can do is you can cross multiply and divide. We can go like this. What is 1 times 6?
6.
6. And then we take that and divide it by that. What's 6 divided by 2?
3.
And it still comes out to be 3, right?
Yeah.
So let's go ahead and take a look at this problem again. Can we multiply anything to go from 8 to 20?
No.
No. So what should we do now?
You can.
You want to do the cross multiply and divide? All right. So let's go ahead and do that. So let's cross multiply these two. And what do you get when you multiply those two numbers?
120.
120. So why don't you go ahead and write that down over there, 120. And our next step is we have to divide it by this other number. So we're going to divide 120 by what?
8.
Perfect. So go ahead and work that out.
40.
So you
So
got
1,
to it. So what was
2, 3, 4, 5.
it? Right. So it comes out to be nice and even, right? Because you went 8 into 12 was once. Brought down your 4, brought down to 0, 8 into 45 times. So if the tree has a 20-foot shadow, how tall is the tree?
15.
All right, so go ahead and put it up there. And it is 15 what?
Feet.
Feet. So we know the tree is 15 feet tall. So go ahead and read this one more time.
A 6-foot man has an 8-foot shadow. How tall is a tree with a 20-foot shadow?
And the answer is?
15 feet.
And was it less than the shadow?
Yes.
So you were correct knowing that it was going to be less. We just had to find out exactly how much less, right?
Yes.
Caitlin, perfect work. All right, welcome back. Do remember we have phone tutors available until 5:30. Every time you phone in tonight, you've got about another 20 minutes or so to be able to get on air. And then next week, you'll automatically win yourself 2 tickets to Holiday Lights at Com. We'll be visiting Marylou out at Com in just a little bit. But first, we have Vienna in studio, and we have a better working microphone on you now, so everybody will be able to hear you. Let everybody know, once again, where you go to school and what grade you're in.
I am in 3rd grade and I go to school at Ronald Reagan Elementary School.
All right. Now, you have an older sister, and she's in junior high already, right?
Yes.
And do you help her with her homework?
No.
Well, after today, you're going to be able to, all right?
Okay.
All right, you know what? What we're going to do is right now what we're going to do is we're going to go to the phone. So I'm going to have you listen and see if you can work out this problem in your head while these guys work it out on the board. All right? Tarek, how are you this afternoon?
Oh, I'm very good.
And are you in 7th or 8th grade at Tevis?
I'm in 8th grade.
All right, as soon as you're ready, Tarek, let's hear the math problem that you're working on.
It says, wait, I think it's, no, never mind. Alright, so you have the worksheet or whatever?
So go ahead and start again.
Alright. So there's a problem at this time.
All right, so Tarek, so can you read the problem to me?
Alright. So it says, what is the rate change? What is the rate of change at Big Time Gym? And at Big Time Gym, it says Big Time Gym charges $20 to join, and then $8 a month. And it's comparing it with a different gym. It's called the Wet 8 Out Gym. And the months are 0, 1, 2, 3, 4, and the total cost is 0, 12, 24, 36, 48.
All right, so I've got the problem here that they wrote down. So the rate of
okay.
change, it's $20 to join whatever it is they're getting into.
$20 to join, right?
And then it's $8 a month.
And $8 a month. $8 per month.
And you're going to make yourself a little chart here.
And that's
Okay.
the first gym, right? And I think this is the second gym? So
Right.
There's 2 gyms.
So is that correct, Tarek? There are 2 different places?
Yeah.
Okay, so that must be the first one.
Yeah.
That's the first one?
Here's the second one.
Okay.
All right, so the second one for month 0. So you're going to make a chart.
Oh,
It's a
okay.
T-table.
Okay, so for month 0, the cost is obviously 0.
Yeah.
For month 1, the cost is 12.
Month 1, the cost is $12, right?
For 2, it's 24.
Oh, I can see you.
3 is 36.
Wait, I can see you right now.
That's good.
You're on YouTube?
And then 4 is 48. That's all of the information that we have. So Tarek, if you can see everything clearly, that's excellent, but just make sure that you keep the volume on the TV set down and just listen over the phone. It'll make everything a little bit easier.
Alright.
All right.
All right, so Tarek, it looks like you've got 2 gyms, is that what you're saying? It's one of them is $20 to join, and then it's $8 per month?
What, can you repeat that?
You're looking at 2 gyms to join, is that correct?
Yes.
2 gyms. So the first one is $20 to join it, and then $8 per month. Is that correct?
Yeah, I think that's, yeah.
And the second gym, they just give the monthly, right? Month 0. So after 1 month is $12, 2 months is 24, 3 months is 36, and 4 months is 48. So do I have all of the numbers that you have?
Let me get one.
Okay.
I believe that's going to be the information, and we'll just go ahead and go with
So
that.
Tarek, what's the question now?
Which joint? I'm assuming it's which
The
gym.
question is, what is the rate change at Big Time Gym?
What is the rate change at which gym?
Big Time Gym.
Is that the first one? Or the second one?
All right.
So Tarek, which one is Big Time Gym? The first one or the second one?
The second one.
The second one. So this is Big Time Gym. Big Time. And what's the first one called?
Yeah.
What's the first one called?
No, it asked me the rate change for the second, the Big Time Gym, which is the second one.
Okay. So the rate of change is what? How much it changes per month, right? How many dollars per month? Is that the rate of change?
Holy.
Okay.
So it's $12.
So the rate of change is how much it changes each month, right?
Yeah.
So from each month it goes up $12, doesn't it?
Yeah.
So it looks like the rate of change is,
$12.
it looks like it's $12 per month.
Oh, not
right? Rate of change is $12 for every 1 month. How's that? Is that the rate of change for that second gym? Okay?
Wait,
Okay, is that the only question they're asking?
so for sweated out gym, no, I messed up. Big time gym is the first one. I accidentally met
So go ahead and do it for the first one now.
the first one, yeah.
So I guess big time was the first one.
So the rate of change is only going to change $8 per month, right?
Yeah.
So even though it starts at $20, it's going to be just like here. Month 0 should be, well, it should be $20 just to join, right?
Yeah.
And then if you do $8 per month, I'm going to add $8, and that's going to give me $28, isn't it? And if I add $8 more, it's going to give me $36. So I'm just adding 8 each time. Is that correct?
Yes.
Add 8 more, it looks like it's going to be $44. Is that right?
Yes.
And one more, since we're doing 4 months, let's do 8 more, and that's going to be 52. So here the rate of change looks like it's just $8 per month, isn't it?
Yeah.
All right, and you have that information, so if they have something like, at what point will
Yes.
you have spent $36, it would be 2 months for the one and then 3 months for the other one. So there's a variety of questions that he could possibly
Right.
answer with that.
Which one would be the best gym to join? Right.
Right,
Okay.
after however many months.
All right.
So.
And then another question that I didn't get correct. It says which gym has a lower initial cost.
So the lowest initial cost is when you first join. This doesn't cost anything, does it?
Right.
It's
Yeah.
0, but the first gym, it costs $20, doesn't it?
Does that make sense to you?
Yes.
Okay.
Yeah. So they're just making
yeah.
sure you understand how they're paying, because one, you pay more every month. It's $12. This one seems like it's better because it's only $8, but it costs you $20 to start. Okay?
Yeah.
So
And it tells me right here which equation relates the cost Y of joining Big Time Gym for X number of months.
okay, and Big Time Gym is the first one, right? So if you're going to be there for X months, right, the total cost, right, I'll use that for C. I don't know, did they use C? It's going to be $20, right, to start with. That's just the initial cost, plus $8 for how many months? You said 8 months, didn't you? Excuse me, X
$8
months. $8 per month, and you said we're going to use X for the number of months?
Yes.
So it's going to be 20 plus 8X. So that should be the total cost of the Big Time Gym. Okay?
Great problem right there. And do remember, if you have some more like that, we do have phone tutors available until 5:30. All right, did you know how to do that question while they were talking about it?
No.
That was a little bit difficult, right? I think he was in 8th grade working on that one, so you're
Lot
in
of-
3rd
lot
grade
of
right
numbers.
now. And you're working on some multiplication. So head on over to the board right there. And I'm going to choose one of the word problems that is part of your homework. The 3rd grade students are traveling to the Science Museum in 8 buses.
8 buses.
So is there any information you think you need to write down so far?
Write down 8 buses. Nice.
There are 40 students on every bus.
No.
We'll just write down 40. We'll figure out what to do with it.
Sure.
So you have 8 buses and you have 40 students on every bus. The question is, how many students are going to the museum?
Oh, so you're multiplying, huh? Why are you multiplying? That's a good.
Because,
Interesting.
oh my gosh. There's 40 students and 8 buses, so 40 students go on
Each bus?
each bus.
Right, and if there's 8 buses, so you'd have 40 students and 40 students and 40 students and 40 students. Well, that'd be doing too much, right? Adding 40 all that time?
Yeah.
I agree with you. All right. How do you want to multiply this?
So I'm going to take away the 0 and multiply 4 times 8, which equals 32.
Nice.
And then I add the 0 to it.
And you put the 0 back on at the end. I like that method. How'd we
Nicely
do?
done. So she's already got the easy way to do it. Just go 4 times 8 and add 0, right?
That's nice.
Get over here. We're going to have to find a harder one
That
for
was
you to
too
do. So
easy.
come on
Yeah.
over here, Vienna. While we find another problem for you to work on that's going to be a little more difficult, we're going to go back out to COM, check out all the lights once again with Marylou.
Hi, Mike. I am back here with Josh Barnett, the mastermind behind this wonderful holiday lights at COM, and it truly is a winter wonderland out here. As the sun is going down, lights are popping up all over the place and amazing things that you don't see during the day. Now, kind of tell us what's new here that you add every year.
Yeah, so we always add new displays and exhibits. And right behind us is this Chinese lantern snowflake, and it's new this year.
And it's beautiful.
Thank you.
And you said you made this.
We did, yes.
Can you tell us how you guys made this?
Sure. Well, we start with a pattern, and then we bend the steel. You can see these are our pieces of steel here. We bend that steel into the shape of the snowflake, and we then put the lights on the inside, run all of our wiring, and then we cover it with fabric.
Now, you talked about the fabric because this is real special fabric. How did you find the fabric?
So we went through an exhaustive search to find just the right fabric because it had to be fire retardant. It had to be durable in the rain. And so we went through many different versions until we settled on this one. And we actually have 3 snowflakes out here. Each one is in a different fabric, so we can see which is going to be the best.
And they're really beautiful.
Thank you.
And let's go. This is my favorite part of the park, is the Winter Wonderland, because there's so much happening here. With the drops, and honestly, it does snow. Can you tell us a little bit about the snow?
Sure. Well, this is our center of our park. So kind of it forks into here. So you come in here, we have the trees lit with the blue lights with the snowdrops falling down. And then as you're entering, we have snow that comes down on our guests. So over here is our snow machine. This is a snow machine like you would see in theatrical applications. And it's not real snow, unfortunately. Yeah. But we take snow fluid, which is here, pump it through the machine, and out comes snow.
That is truly amazing. I love it. It's just, what you guys have done is just so beautiful. Everything, putting it all together. Now there's these signs, sponsor signs all over the park. Can you kind of tell us a little bit about the sponsors?
Sure. Well, the sponsors are a big part of Holiday Life. Without them, we wouldn't be able to do everything that we are doing. So we really do appreciate everything that they do for us.
Now, there's lots of events out here. Can you kind of tell us a little bit about the events that occur out here?
Sure. Well, we actually have some private parties that occur. There's a tent at the front of the park where different companies, tonight they're doing an event there. So every night.
And then there's caramel corn, right?
Yes,
there's caramel corn.
Kettle corn, hot chocolate.
All that fun stuff.
Yes, you definitely have to get that.
Now, these are nude, which is absolutely fantastic. They're like movable lights. Can you kind of tell us a little bit about that?
So we used to just have silhouetted displays, and within a couple of years, we decided to fill them in. Instead of just having the outlines, we wanted to have it more dense with light. So the one there in front of us is our snow hill, and it's all filled in with lights.
Now, silhouetted.
Yeah,
like
silhouette's just like that lamppost.
Okay.
Yeah.
So it's almost like now it's movable.
Yeah.
Very cool. Now, talking about the little sled there, there is a great part of this park, and that's the train.
Yes.
Can you tell us a little bit about that? Because I love the train. It's so much fun.
Yeah, absolutely. The train runs on the outside of COM, and we have several exhibits out there. Bakersfield Landmarks. We have Santa's North Pole with a toy factory, and other exhibits, and a light tunnel.
Oh, you have a light tunnel.
Yes.
Now, I know you have the dinosaurs too,
Yes.
which are out there,
Yes.
which are beautiful. And in the front, when everyone comes in, there's also a carousel out there.
There is, yeah.
And is there any other activities going on around that we haven't mentioned yet?
You know, I know that a lot of the animals are sleeping, but I know up towards the front there's some porcupines that are awake. There's some owls that are awake, so you might see some creatures that out here as well.
So we'll be able to actually see some animals as well. So much fun. I have to thank you so much, Josh.
Thank you.
What you have done out here for the last 13 years,
Yeah,
yes?
13 years.
Absolutely fantastic.
Thank you.
Thank you again. And back to you. And don't forget, it started on Black Friday and it goes till January 3rd. Starts at 5:30 at night, opening at 5:30 at night, and closes at
I believe 9 o'clock.
9 o'clock. You have to come out here. It's fantastic. Back to you, Mike.
Thank you very much for that, Marylou. Nice that we had the beginning and ending time out there.
Yeah.
So somebody doesn't get out there too early, like, I got to school at 3 o'clock, let's go to Holiday Lights. Well, maybe go get something to eat first and then go out to Holiday Lights. But also that it ends at 9 o'clock because it takes a little while to get through all of those grounds out at COM. 636-4357 is the phone number. Right now we'll go back to the phones. A student from Berkshire. Ruth, how are you today? Hello, Ruth. Are you
Good.
there? Yes, how are you today?
Hello?
Hello? You there, Ruth?
Good, and you?
I'm wonderful myself. What grade are you in, Ruth?
Yes?
Ruth, turn the TV set down. That might be the delay right there. And she probably heard that now. So turn the TV set volume down and just listen over the phone. And as soon as you're ready, Ruth, let's hear the math problem that you're working on. There it is in the background.
Okay.
Okay, so Ruth, can you tell me what the problem is?
Seven.
7, okay.
Parentheses.
Open parentheses, I tell you. Yeah.
2.
Yeah, okay, just go ahead and read the whole problem.
Minus.
Mm-hmm.
X, and then the parentheses n, and equals
And equals,
3.
Then open parentheses. And I've got the problem here in front of me, Ruth, that you phoned in with. X plus 8.
x plus 8. Okay,
Close
got it.
parentheses. And then, Ruth, just make sure that is the problem. Is that it?
Yes, it is.
Okay, so let's go ahead and work through the problem. You can see as we're going through. Excuse me. So the first thing, we have to remove the parentheses.
Do you have water over here? Oh, all right,
right.
sub in there.
Tapping out, all right. So we're going to go ahead, and what Chuck was saying was you're going to remove the parentheses by doing the distributive property. So we're going to go ahead and multiply 7 times 2, and 7 times 2 is?
14.
Good. And then 7 times negative x?
Negative 7.
Negative 7x, right? Because when we multiply 7 times x, you just kind of smush them together, 7x. Now that we've actually distributed the 7 in, you don't need the parentheses anymore. And now you can hit your equal sign. We'll do the same thing on this side. So we're going to multiply 3 times x, which is?
3x.
Beautiful. And then 3 times 8?
24.
Nice, 24. And then you bring your plus sign straight down because you multiplied a positive times a positive, which is a positive answer. All right, now, do you remember what to do now, Ruth?
Not really.
Okay, so see how we have x's on both sides of the equation?
You have to
We need
get
to-
rid of the x's.
Yeah, well, we're not going to fully get rid of them yet. We're just going to get them on one side. And it honestly does not matter which side you get them on. So you could move the 7 over here, or you could move the 3 over here. A good rule of thumb, though, is if you have a negative value on one of the x's, you might want to move that one over just so that you can add. Because what's the opposite of subtracting?
Adding.
Adding. And I always like to deal with positive numbers anyway. So I'm going to pick the 7 to move it over. So I'm going to add 7x here, and I'm going to add it over here because we're dealing with an equal sign, right? So we have to keep our equation balanced. So we've just changed this side, so we have to change this side the same amount. So if I add 7x here, I add 7x here, okay? So now, what happens with the negative 7x and the positive 7x?
I guess plus out because it turns into 0.
Right, because if you add 7x and then you take away 7x, you have no more x's left. Very nice. So what happens here when you have 3x's plus 7x's?
You get positive 10x.
Very nice. Positive 10x's. And now I'm just going to bring everything down that I haven't messed with. So I'm going to bring down the 24, and I'm going to bring down the 14. There we go. So now see how we have x's just on one side?
Yes.
Which is really nice. So now the whole goal is to get x all by itself so that my final answer is just going to have x alone on one side and then my answer is going to be on the other side, okay? So I've got to get rid of the 10, and I have to get rid of the 24. But which one do I get rid of first? That's the question.
The 14?
The 14, now notice the 14's on the other side. He's not even messing with x. So I'm going to leave the 14 alone. So we're going to get rid of the 24 first, because you see how x is being multiplied by 10 first and then adding 24?
Yeah.
So we're going to start with the 24 to get rid of him. So we're going to move him to the other side. Well, what's the opposite of adding 24?
Subtracting 24.
Good. So I'm going to subtract 24 here, and on the other side of the equal sign, way over here, which is minus 24 here. All right. So what is 24 minus 24?
0.
0. So that's gone. So what is 14 take away 24?
Negative 10.
Ooh, good. Good on the negative. Okay. And that equals, I think I just have 10x left over here, right?
Yeah.
Okay. So now, is my x by itself?
Yes.
It's close. It still has the 10 stuck to it, though, right? So now I got to get rid of the 10. The 10 is being multiplied by the x. So what's the opposite of multiplication?
Division.
Good. So I'm just going to go ahead and divide both sides by 10. So what is 10 divided by 10 here?
1.
1. And 1 is the same as 1x is the same as just saying x. So you don't have to say 1x. You can just say x. So I'm going to go ahead and erase the little 1 there. And what is negative 10 divided by 10?
Negative 1.
Negative 1. There you go. So there's your answer. We've got x all by itself, and x equals negative 1. And you might want to double check on that, plug it back into the original equation at home, make sure it works. But I'm pretty sure we did it right.
Nicely done. Thank you for that call right there, Ruth. And Ruth is now going out to Holiday Lights at Cannes to see those 3 million plus lights. All right, we have just a moment or so. So Vienna, back to the board. And you know what? No, stay right here. We're going to make you do this in your head.
All right.
All right, here we go. Because you have a lot of the multiplication problems on here. We gave you some word problems. Now we're just going to do the straight multiplying, all right? So I want you doing these in your head. So when we have 30 times 8, what is 30 times 8?
240.
240, exactly. How did you do that?
I did it the smart way.
The smart way, indeed you did. But what did you multiply in order to get that answer?
I multiplied 3 times 8 equals 24, then I added the 0
right?
at the
So there
end.
you go. So 240. 60 times 7.
420.
Correct. 70 times 4.
280.
Good. So you're on a roll. So you feeling good with this?
Yes.
All right, here's what we're going to do. We're going to have you select the winner who's going to see the Bakersfield Condors, all right? Out of all of the students that phoned in, one of them is going to go see the Condors as well, all right? So go ahead and reach your hand in there and pick one out, and then you can read the name.
Kyle.
All right, so Kyle from Singlum Elementary, congratulations. Got yourself a couple of tickets to the Condors, as well as tickets to Holiday Lights at Cannes. Remember, we'll do the same thing next week, both Tuesday and Wednesday. We do have phone tutors available until 5:30 today. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.